Okay, guys, once again, I welcome you to my lesson for today, where we'll be looking at physical sciences. So, remember, for those of you who are attending my lessons for the first time today, remember that at all times, I do record this type of lessons which are being recorded and again posted on my website. So my website over there, as you can see, www.solveexampapers.co.za. So in case if you missed any of my previous lessons, you can still make use of that website to catch up on my previous lessons. And most importantly, guys, before we treat any past exam papers, I make sure to give a background of what the chapter is all about, so that when I solve exam related type of questions, I can refer to that specific lesson that I had. And remember, guys, that lesson is being recorded. I mean, it has been recorded and it was posted on my website. It could be that it's in the queue because I don't post all at once. So I also do some private lessons of which you can inquire about those via inbox. So guys, without any waste of time, as you can see over there, I try to draw an aeroplane. So someone is going to be a pilot, guys, and you will see and notice how beautiful that drawing is. So for now, let's forget a bit about the beauty or the looks of that aeroplane and quickly read through the given statement. So in today's lesson, we'll be looking at question 3 of one of the previous question papers, where you are advised to start on a new page. Remember, guys, this question paper is posted in the group. I just posted it recently. So on your screen, there should be somewhere you can click on back to access this question paper. So what I'm going to do is to quickly read through the given statement, do a bit of interpretation. From there, I'll be going through all the questions. So I will also give you guys an opportunity to engage in each and every question that we'll be answering. And most importantly, guys, especially to those who are attending my lessons for the very first time, guys, a very warm welcome to you. And most importantly, just be aware that I welcome both answers, an answer being correct and again an incorrect answer. And I welcome incorrect answers because they are able to make me to expand my explanation. So I explain and dish out more when I notice where the problem could be. So guys, the statement reads as follows. A hovering rescue helicopter has a container of supplies with a weight of 1,960 newtons. Listen very carefully. 1,960 newtons. Hanging from a cable. Full stop. The tension in the cable is, listen very carefully, 2,100 newton. Very, very much important, ladies and gentlemen, at all times, that when you read the statement, take your time, make sure that at the same time while you're reading, you translate to your home language so that you better understand what information is presented before you. So I'll just read it for the last time. A hovering rescue helicopter. So that means in this case, we're talking about an helicopter which is hovering somewhere in the middle of the air, and it has a container of supplies. As you can see over there, there's an aeroplane, there's a container with a weight of 1,960 newtons. Very, very much important, guys. So the question is that 1,960 newton, is it the weight of the helicopter or is it the weight of the container supplies? Very, very much important, guys. So you need to ask yourself those type of questions when you read through the given statement. So obviously, in this case, there's nothing tricky about that. We know very well that the weight of 1000, let me just write the weight over there, it is equals to 1960 Newton. Guys, remember, weight is a vector quantity. Let's do that to indicate that weight is a vector quantity. What does it mean when weight is referred to as a vector quantity? It means it has both magnitude and direction. What is the magnitude of the weight? It is given as 1960 newtons. Very, very much important, guys. So now that we know weight is a vector quantity, in which direction is the weight? Obviously, downwards. So someone can use the weight downwards, because obviously that container of supplies is hanging somewhere in the middle of the air. So it has a weight which is going in the direction of downwards. So obviously, assuming that this is the F, so that weight is vertically downwards towards the center of the earth. We know very well what I'm talking about, because we did discuss more of that in those lessons when I was teaching different types of forces and when we were going through each of those forces. So guys, just make sure that when you treat this type of question papers, get yourself a glass of water. If you like piano, you can just be playing your nice music there. Just make sure that you relax, you stay calm, you read very carefully, you take into account the numbers given. Do not write 1980 newtons by mistake there, because you are most likely to perform incorrect calculations because of that one simple mistake. So the statement continues: the tension in the cable is 2100 Newton. So there is the cable, ladies and gentlemen. There is the cable. So we obviously know that in the cable we've got tension. So it is given a magnitude, and they say the magnitude of the tension in the cable is 2100 Newton. Guys, what is that 2100? That is tension. So it is the magnitude of the tension. Guys, is tension a scalar or a vector quantity? Guys, tension is a force. Therefore, it's a vector quantity. What does it mean if force is a vector quantity? It means it has both magnitude and direction. Ladies and gentlemen, in which direction is that tension? Obviously, upwards. So let's write it there, guys, to say upwards. It's going to come in handy when we go deep into our calculations. Very, very much important, ladies and gentlemen, that at all times, when you are doing your revision or whatever that you call it, especially in lessons similar to this one, we move at a slower pace while enjoying all the information being provided in the lesson. So, guys, that is all that we have. So it's more like we've got an aeroplane which is standing somewhere in the middle of the air, and then it has got that cable which is attached to a container of supplies, and we were told the tension in the cable is 2100 Newton. And again, surprisingly, the weight of that a container of supplies is 1,960 newtons downwards. So these two forces, guys, are not balanced. They are not balanced. So if they are not balanced, it means the one with a greater force, it's going to influence the motion of the object. In short, what am I saying, guys? I'm saying, let me see who's on the line. The first one I notice Koketso. If we have Koketso there, pulling a rope or a string, who else is on the line? I see Ndiwe. There we've got Ndiwe, ladies and gentlemen. So they've got a string over there. We have Koketso there and Ndiwe there. Koketso is pulling in that direction at a magnitude of, let's say, 20 Newton. So remember, guys, this is the force that Koketso is applying to pull that string in that direction. So the force is 20 Newton. Remember, force is a vector quantity, so it therefore has a direction. So that means it's 20 Newton westwards. Let's now have a look at Ndiwe. Ndiwe is also pulling in that direction. Let's say, for example, at, let's say, 50 Newton. So in which direction? It's in the eastwards direction. So guys, can you see both of these? They are pulling, but now this one is pulling in that direction at 20 Newton, this one at 50 Newton. If the direction is in that direction, what do I mean by that? I'm simply trying to say, if this force is able to pull Koketso in that eastwards direction, it means there's more force being applied in that direction. That is the reason why Koketso is also being pulled in that direction, because she's pulling a lesser amount of force. But now, what if they say, even though Ndiwe is pulling at 50 newtons, and again Koketso is pulling at 20 newtons, but still Koketso it's not being pulled in that direction or towards the eastwards. Then, because we are dealing with physical sciences, guys, this is not a magic, it's a science that is physical. Very, very much important, ladies and gentlemen. So that means there must be an extra force that is being pulled in that direction to make Koketso remain exactly at that point. So what could that force be? It has to be nothing else other than force of friction. What do we mean by force of friction? We mean, even though Koketso is pulling at a lesser force, but there is an additional force in that direction which is making both of these forces to balance. So how much is that force? It has to be 30, ladies and gentlemen. It has to be 30 newtons. Why 30? So that the forces being applied on that side versus the forces being applied on that side are equal. When they are equal, no one is going to move in any direction. But the moment there's an imbalance of forces, then the greater the force, it will influence the direction in which the movement will be. I hope that part makes sense. The reason why I had to explain in this way is because it's not always where you are going to have vertical forces which are not balanced. Sometimes you might have horizontal forces which are not balanced. And again, you might also have those type of forces on an incline. You just need to make sure that you don't miss any of my lessons, because more of that type of information will be discussed. So, ladies and gentlemen, is there someone who wants to guess just for argument's sake, it's not like we are answering any of the questions. So just get ready. Remember, the rules are, if you are commenting for the first time, just mention your name, make your point straight away, then mute your mic. Do not unmute your mic and call for my attention, because you might find that our communication is not instant. Like I'm saying now, you might find that what I'm saying now, you'll only get the message after a few seconds. So just make sure that the moment you get a question, unmute your mic, mention your name, make your point, mute your mic. So here comes a question, guys. Just for discussion purposes, do you think these two forces, the upward force and the downward force, do you think they are balanced? If they are not balanced, do you think the container with supplies is going to move? And if it's going to move, in which direction is it going to move? That is the first question. So I'll open responses to that question.
Yes, I think they are not balanced because
Grace, I think they are not balanced.
Thank you very much, Grace. And the reason to that, remember, I think I extended my question to say, are they balanced? And again, if they are not balanced, do you think there's going to be a movement? And again, in which direction will the container move? Will it be downwards or will it be upwards? And again, whichever direction you choose, give a reason for your answer.
The forces are not balanced because tension is greater than weight. Then the container, I think it will move upward.
100%. Ladies and gentlemen, that question is sealed. I welcome all the responses. It's a physical science. We can see what is going to happen over there. So now, here comes another question. What if, even though these two forces are not balanced, what if this container, it's not moving upwards? Is it possible that even though the tension versus the weight are not balanced, this container can still remain in that position? What could be the reason to that?
So, Tisha speaking. Yes, they can. It is possible that it doesn't move upwards because it's in the air. So, as we know that everything that's in the air, like gravity pulls it down, so it will stay and it will not move up because of gravity, because gravity will be pulling it down. That's what I think.
Thanks very much, Tita. The second one to also make their point. Remember, guys, I'm not expecting any correct answer. I'm expecting any possible answer or anything that you can think of. So it helps when you give me answers which are raw from your mind, because it's going to help me to explain even more. So another one to give it a try.
so I think it is impossible for it to not move because there is an external force which is
Did
in the
did
downward
did
direction.
you did you say it's impossible or it's possible?
Impossible, say.
Or so you're saying it's impossible that, maybe make your point, Lerato. Make your point.
I think so it's because there is an external force. If there was no external force, maybe it was going to not move, maybe.
Or so you're saying it has to move. Nay, that's what you're saying, nay.
Yes, because the force is
Okay, no. All right, no, I get it. So you're saying it has to move because the forces, um are not balanced. And again, you're saying it's impossible for it to remain in that position. Okay, if I heard you correctly, is there someone, the last one, to just give their last comment, their peace of mind? Remember, guys, we may be conducting this lesson in English, but otherwise, if you are somewhere in Venda, give it a try. Give it a try in your confident language or whichever language that you prefer. Then I'm sure there's someone who's good in other languages that will help us to translate. I just want to make sure that everyone is included, because just like myself, when I was still in high school, I wasn't confident in English, so I had to ask everything in my home language. And study more to understand these physics terms. So you don't need to worry that much about you not being confident with physics terms. You will as time goes on, as long as you keep on attending this type of questions, this type of lessons. Guys, the last one to make their comment. Okay, so what I'm going to do now is to give an explanation based on what I understood from Tita. So Tita said, what is it? I think she said it's impossible that this container with supplies is going to move, because there is an external force, which is a weight, and is pulling that container downwards. If that is my understanding and is correct, I'll just continue to explain. But if it's incorrect, Tita, just make sure that you correct me. So let me do a dot over there which represent the container of supplies. Then we have a force of tension which is 2,100 newtons in the upward direction. Then we have this smaller one, which is the weight, which is 1,960 newton. Remember, guys, weight and force of gravity, it's exactly the same thing. So, Tita, I wanted to say these two forces, first thing first, they are not balanced. What does it mean when these forces are not balanced? It means this container is going to move in the direction in which the greater force is being applied. So it's more like this thing is pulling harder than this one is pulling downwards. So that means this object, it is going to move in that upwards direction, because there's an extra force in that upwards direction. Let's now have a look at another option. So let's say the tension there was 2,100 newton, and the weight as a result of a force of gravity theta, let's say, is a weight. We know weight and force of gravity is the same thing. Let's say it was 2,100 newton. In this case, this container of supplies was not going to move, because both of these forces are balanced in opposite directions. It was just going to stay, to stay there in that same position forever. So now let's have a look at another situation. Let's say we've got that, and that object, it has got a tension of, let's say, 30 newton, and again we've got that weight. Remember, weight is the same as Fg. Let's say it has got 50 newtons. So in this case, we were going to have that container of supplies pulling or moving in the downwards direction. Why? Because these two forces are not balanced. And again, that one of 50 newtons, it has got more force than that one of 30 newton. That's why it's going to move downwards. So that is a response to Tita's comment. And Tita, thanks very much for sharing a piece of your mind, because it helps others to also understand as I explain this information. Tita, before I attend to Lerato, did that explanation make sense to you and everyone else?
Yes, I did understand. I didn't know that. Like I get confused with weight because my teacher mostly uses FG instead of weight. So,
Oh, yes. Yes, okay.
and
No.
yeah,
Um,
my name is Tisha, not
oh,
Tita. Yeah,
Tisha.
Tita is my little brother's. My little
So,
brother calls me that.
guys, I'm from Limpopo, guys. In Limpopo, we just call it as, oh, Tisha. Okay. Uh, Tisha, thanks very much for all of that. So, um, I'm glad you did understand that. You see, guys, that is the reason why I'm saying just speak peace of your mind, because now Tisha has learned that weight is actually the same thing as force of gravity. What is force of gravity? Force of gravity is G. What is mg? Mg is weight, ladies and gentlemen. So now Tisha is able to see that on that formula of mg, or in that weight, being weight, we do have G, which is a 9.8. And then in terms of the mass, it depends on whatever the object is. So now can I move to Lerato's comment? I think I might need to remove let me see. I might need to remove all of this information. I hope it made perfect sense to everyone who has attended this lesson. So guys, remember, I'm not able to see who has attended um, the lesson unless if I make efforts to check. But otherwise, just make sure that if you are speaking for the first time, mention your name so that I can pick up from your voice when you speak on upcoming lessons. So I remember Lerato also made a comment to say it's impossible that this container could remain in that same position. Is that what you said, Lerato? Did you say this thing can? What did you say?
Yes, it's and I gave a reason that there is an external force which is acting in a downward direction and the motion is in an upward direction.
Wait, you said this container is impossible for it to move, or did you say it's going to move?
I said that it's impossible for it to stay at rest
Oh,
or at rest.
so in which direction is it going to move?
Upward, so
Okay, now I remember. So, guys, in response to Lerato's comment, I think Lerato was answering my question of, is it possible that even though these two forces are not equal, is it possible that this container can remain the same? And she said, no, it's impossible. It's going to move. So, this is a response to my question. So here, Rato, check. We have tension which is equals to 2,100 Newton. So now we already have weight which is equals to 1,960 Newton. So I was saying it is possible. In my response, it is possible, guys, that even though when you compare the force of the tension and that of the weight, they are not equal, but it is still possible that this container can still remain there. And the reason to that is because you might have a frictional force which balances the two forces, making this container to remain in that position. So, uh, what I can agree to, Lerato, is that maybe my question wasn't clear enough for you to be able, to expect that I might be expecting an answer similar to this one. But otherwise, it doesn't really matter that much whether what the both of you guys have said is wrong or correct. I just wanted us to have an engagement, just to have a discussion where we can explore and go beyond just the information that is being provided to us. So guys, just bear in mind that every time when we have a lesson, it's not really about answering the questions, but we have to talk about these things because they come in different ways, in different packages. The level of complexity is not the same for each and every question paper. But when we have such discussions, that's when you are able to notice and learn some new things. Guys, a day without learning something new, it's a day wasted. So please do make sure that by the end of each and every lesson that I conduct, you learn some new. Very, very much important, guys. Do not just attend a lesson and be happy that all the questions were answered, but you did not learn anything new. Lerato, are you happy with that response to say, even though the two forces may not be equal, but it is possible that this container can remain in that position? And the reason to that is because we might have frictional force which balance the two forces. Lerato, are you happy with that?
Yes, I understand.
Okay. 100%. So, guys, I think we have discussed enough for us to be able to try and answer the questions. So, you will see that our questions will actually be based on what we just discussed now. So, if you were listening very carefully, of which I assume you were, you will fully understand what's going on over there. And again, remember, guys, all of this information that I'm using to solve these problems is not because it's coming out of my head, but it's because I made some time to prepare for a lesson where I study some notes, prepare some notes, and I did a lesson where we discussed all that you had to know regarding mechanics. So let's now attempt our very first question, which says, state Newton's first law of motion in width. Good people, what is the cream of the question? And again, what do I mean by the cream of the question?
So I think you mean what you are required to state by the time of the question.
Lerato, I did not get that part. Remember to put your mic closer.
I think you mean what are we required to state.
Lerato has given a response to my question. Anyone else who wants to give it a try?
I think that the cream of the question is stating the first is it the first or the first
Yes.
law of Newton? Yeah, the first law of Newton's law of motion. Yeah.
So, Lerato, which means next time when I ask a question, you can firstly refer to my question. For example, my question was, what is the cream of the question? It did not end there, Tisha. So, make sure that you reference to my question. So even though it's a response to my question, but remember, guys, remember, the cream of the question is that word or those words when removed from a sentence or a question, the whole of it will not make any sense. So when I look at that question, Lerato, and if I remove state, I'm sure you say it, state is the cream of the question. So when I remove state, we remain with Newton's first law of motion in weights. So can you see, I can still guess what the question wants me to do based on those remaining weights. But when you remove Newton's first law of motion, so when you remove the whole of that, you remain with state in words. Can you see? State in words, it doesn't make sense on its own. So that means the cream of the question, it has to be Newton's first law of motion. So those other words, state and in words, it guides you in terms of how to provide an answer to that question. So that means you must state, and again, you must state in words. Remember, you can describe Newton's law by making use of the formulas. So it is necessary for the examiner to say, state Newton's first law of motion in words. And again, Tisha, remember, my question was divided into two, of which I wanted that cream of the question. And again, even though I've provided an answer, the other one, I wanted you guys to tell me that when we talk about the cream of the question, we refer to that word or those words when removed from the sentence. It remains senseless. Remember, some of you guys, especially Lerato, you've attended most of my lessons. You already know at this point what is the cream or what is meant by the cream. But just so that we inspire those who attended my lessons for the first time, they will be able to notice that we've got a culture of, approaching questions. So, guys, the cream of the question is Newton's first law of motion, of which I assume everyone in this group knows at this point in time what is Newton's first law of motion. So someone can just quickly state Newton's first law of motion. So just make sure that you are not reading it from somewhere, say it from the top of your head. So this question is given 2 marks. Someone wanted to give it a try straight from your head. Just give it a try, guys.
So may I try? Newton's first
Go
law of
for it.
motion. Newton's first law of motion stated an object will remain at rest if will remain in its state of rest or air will move at a constant velocity unless there is an unbalanced force acts on it.
Okay, so guys, my advice to you is that just make sure that you know all of those laws by heart, because if a question comes, you just give it exactly as it is or exactly as you understand it. So we can now move to the second question. So, guys, the second question says, draw a labeled force diagram of all the forces acting on the container. Here comes the question, guys. What is the cream of the question?
Labeled free body diagram.
Lerato, if they don't say labeled force diagram, what could they expect you to label?
I think the cream of the question is free body diagram. diagram.
Who said that?
T-shirt.
T-shirt free body diagram, she says, is the cream of the question. Lerato, answer my question.
Sir, please repeat the question.
So my question was, whatever that you said, it's either examiner wants that or something else. It's two things. So what is that other one that they might, ask you to label?
They can ask you to label a force diagram.
Tisha has said it. So, Tisha, remember, in this case, the question says draw a labeled force diagram of all the forces acting on the container. Can you correct yourself on that one?
Oh, so it's free body diagram of all forces acting on the object.
So, let's see, force diagram. So what I was saying in short, guys, is two things which they may ask you to do. The first one, it could be free body diagram, which is different from force diagram. So in this case, the question wants you to label a force diagram and not a free body diagram. So you need to be very, very careful of that. So there's a difference between the two, of which it was explained in the previous lesson where we were discussing all of this. So just make sure that whatever that you give, it's an answer to the question. So some of you
Sorry
guys
for
might do.
the question that they want force. I heard like you said free body. Sorry, I made a mistake there.
Okay, 100%. I'm glad you were able to notice the mistake. So now, for the purpose of us practicing, we are going to do both. Let's firstly answer the question. The question wants us to do force diagram. So the force diagram, it means you are going to show that container, ladies and gentlemen. So how many upwards forces do we have? We've got one force, which is that one force in that direction. What is that force, guys? That force is tension. And again, what other force do we have? We have the weight. We have the weight. What other force do we have, ladies and gentlemen? Possibly, and again, remember, guys, remember, this question, it's allocated 3 marks, which means possibly you could be having a how many forces, guys? 3 forces, possibly. So I've been saying this, that the marks allocated to each question, they guide you in terms of how your answer is expected. So obviously, there are high chances that you might be having that third force, which is frictional force. Obviously, the frictional force is in which direction? I think it has to be in the downwards direction. So there you've got frictional force. I'm not sure if you guys are able to understand what I was doing there. So in terms of a free body diagram, this is force diagram. Free body diagram, you just make what is it, a dot over there, then you show the upward force, and then you show the downwards force being force of gravity, force of friction, and again another one being the weight. So that's how you would draw a free body diagram, and this is a force diagram. The difference between the two is because when it comes to free body diagram, you firstly make a dot and you draw the arrows, and all the arrows must point away from that dot. So you cannot not make a dot and again have an arrow in that direction, which is that one there, and call it force of friction. Why? Because they say when you draw a free body diagram, it has to be a dot, then all the arrows has to radiate away from the dot. I hope it makes sense. But when it comes to force diagram, you represent the object by that box over there. Then you show what is it? You show the direction in which the forces are acting. And something very, very much important that I want you guys to be careful of. Can you see that? This is a wrong way of representing the weight. Is there someone who wants to guess why is that the wrong way to represent the weight?
I think so. It's because weight is drawn
The
from the center.
weight have to start from the center.
100%. So when it comes to the weight, that means you draw your box. And then from the center of that box, that's where you show the weight. I hope it makes sense. Then any other forces you can then draw. So obviously, tension cannot start from the center because that cable is attached there at the top of that container. And again, frictional force, you you are most unlikely to show it there, guys. Show it there. Why there? It's because this is the frictional force where it is acting not below the container but above the container. That's where we have the frictional force. So by so doing, guys, they give you your full 3 marks with that starting from the center. And again, most importantly, a free a labeled force diagram. When they say a labeled, show the forces. Don't only just draw a box and then from there you just do that and then you leave it there. You might score yourself some half marks over there. Make sure that you label. You say weight. If you don't say W, you can use FG. It's the same thing. If you don't use force of friction, you can just write F. If you don't use force of tension, you can just write tension. Guys, are you happy with that part before we move to the next question?
So
Yes, sir.
Okay, so let's now move to a 3.3. So I hope everyone has got a question paper in the group. So the question says, why does the container remain stationary despite the tension being greater than the weight? This question is allocated 2 marks. Is there someone who wants to give it a try? So it says, why does the container remain stationary despite the tension being greater than the weight?
It's because there is an external force.
Do you guys agree with that response? So remember, guys, this is what we explained to say the tension is equals to 2100 Newton in the upwards direction. And again, we've got the weight, which is, what was it? I think it's 1960 Newton in the downwards direction. And they continue to say, despite tension being greater than the weight, this container, it's not moving, as we discussed, guys. This container, it's not moving. It is still in that position. What could be the reason to that? Is because possibly there is an extra force, an extra downwards force. Here comes a question. What do you think is the amount of that force that keeps this container to not move?
Yeah, it's 140 from 2100 minus 1960.
So that extra force, it's an amount such that all the downwards forces, when added together, they will give you 2100. So it's more like you have an upward force which is 5 Newton, and you have a downward force which is weight, let's say, is 3 Newton. So for you to balance these two forces, it means you need an extra force. How much is that extra force? It's obviously going to be 2 Newton. Why? So that 5, it's 5 upwards and it's balanced by another 5 downwards. So what did you say, Lerato? What is that amount? So what is that minus that?
Yeah, it's 140 newtons.
So it's 140 newtons. So it's 140 Newton in the downwards direction. So we already noticed that there's a frictional force which has got an amount of 140. So let's now move to the next question. So in short, it means, just to respond to that question, it means there is an extra force, or just like Lerato has explained, examiner was also giving you, was also going to give you a mark for that response. So now, uh, sorry, let's continue. The question says, now the winch inside the helicopter starts to pull the container upwards with an acceleration of 0.13 meters per second while the helicopter remains in its position. So that means now this container is moving and this aeroplane is not moving. So obviously, if this aeroplane is not moving, it means there's that machine which is being referred to as the winch, which is now pulling this container, and this container is going upwards at an acceleration of 0.13 meters per second squared. Very, very much important, ladies and gentlemen. So now, the question says, calculate the mass of the container. So, guys, uh, for the fact that they said the mass of the container, it means the cream of the question is the mass. So your final answer should be a magnitude which is in kilograms. Do not give anything other than an answer which is in kilograms. So from which formula can you use to calculate the mass? As far as I remember, we do have force of gravity, which is the same thing as the weight, and the formula for this is mg. And based on the information that we're given, it seems like we do have the weight. I'm not sure if you guys are able to notice. And again, there we have 9.8, which doesn't change. So we can substitute there, and solve for m. And this question, it's allocated 2 marks. So guys, quickly perform that calculation and tell me what is the mass.
It's 200 kg.
Did all of you guys get the same answer?
Yes, sir.
So you guys divided by 9.8, you divided by a 9.8, that cancels. Then you have the mass, and you guys are saying, what is it? Is 200 kilograms. So they are going to give you a mark for the correct formula and again for the correct answer. And this question is allocated 2 marks. So, guys, is everyone happy with that explanation? Does it make sense to everyone?
Yes, sir.
Okay, 100%. So now, let's move to the next question. So the next question says, calculate the magnitude of the tension in the cable while the helicopter, while the container is being pulled upwards. So they want to know what is the magnitude of of the tension. Let me just make sure that I'm getting it correctly. Calculate the magnitude of the tension in the cable while the container is being pulled upwards. This question is interesting, guys, and I want you guys to just balance me on this one. When this container starts moving, do you think the tension is going to change? And if it changes, is it increasing or is it decreasing?
It will increase.
So I'm struggling to hear Lerato when she speaks. So Lerato, quickly repeat that part or whatever that you said, and again, can someone also make a comment? The question is, um, do you think when that container moves upwards, do you think the tension in the cable is going to increase or decrease? And again, give a reason for your answer.
It will increase.
Sorry, guys, I didn't get that. Who was making a comment? What is it? Guys, are you not sure of that question, or you you don't have an idea? Remember,
So
in case if you don't have, uh-huh.
I'm waiting for Lerato to respond to you, then I'll give you my opinion.
Okay, Lerato, just make sure that you are audible and you share what do you think about that situation.
Sir, I think the tension will increase.
Okay, it's fine. She says it's going to increase, but I wanted to also know the reason if you are able to tell. But otherwise, if you only know it's going to increase, but you're not confident with your reason, it's fine. Tisha, you can also give it a try. We'll hear um, what do you think about that situation.
I think tension will increase, and my reason is that it's because now they told us that it's now accelerating. So it means that, okay, tension will increase. So it means that the tension is now greater than the weight and the frictional force. So that's why, yeah, I hope you get my sense there, because
Yes,
like,
100%. It makes perfect sense. So, so that means you can make comment based on that acceleration. They say because now there's a movement. It means there's an extra force within the tension that makes that container to move. So that means now the tension is going to. So the reason why I asked you this question, guys, is because I wanted you to be aware that when you do your calculations, if you get a force which is less than 2,100 Newton, it means somewhere, somehow, you made a mistake. So now let's try to formulate. And again, guys, when you formulate, always look at your either um, what is it, labeled force diagram, or otherwise your free body diagram. So that one we said is the weight. We know there's a frictional force, and again now there's that tension. So that means when you formulate, you are going to have three forces on your formula. Remember, guys, the formula says force net. What does net mean? Net means total. What does total mean? It simply means resultant. So that means examiner may say net force or total force or resultant force. So what you know is that force, it's a vector quantity. It therefore have it has a magnitude and a direction. So this is equals to MA. Obviously, you know that the formula says F net is equals to MA. So with all of this, you can just choose which one you use. But normally, I think it's a F net. So now, let's see. How many forces do we have? We have three forces. So the first one, we've got a tension, and again, the other force that we have, which force is it? Is the weight. And in which direction is that weight? It's in the downwards direction. So that means assuming a positive to be upwards and the negative to be downwards. That means you are going to have negative W. Why negative? Because this is acting in the downwards direction. So again, plus what other force do we have? We have that frictional force caused by the winch. So that means in brackets you have negative frictional force. Why negative? Because it's also acting in the downwards direction. This is equals to mass times acceleration. Remember, guys, this tension, it's not that tension. It's different from that one. Why is it different? Is because the one that we are calculating, that's when this object or this container is now moving with an acceleration of 0.13. So we can say maybe this is the tension as a result of maybe acceleration down there. Or if you understand your story, then you remember that this is the new tension and it's not that one. So this one also, it has to be bigger than that one. Not necessarily too much big, but it just has to be greater than that one. So now let's try to continue with our calculation. Remember, guys, Tisha, the reason why I did not just say T minus W minus or a force of friction is equals to MA, it's because the formula says F net. What does net mean? It means total. What does total mean? It means you must add the yellow dang. You must add everything. What are we adding? We are adding the forces. Which forces? The forces acting on that container. How many forces are there? it's 1, it's 2, and it's 3. So that means you've got 3 forces. So these forces, in which direction are they acting? So we've got the first force, it's opposite, it's positive there, and then this force, so we can even put that one in brackets, it doesn't matter. So this force is acting in the opposite direction or in the downwards direction, and this one in the downwards direction. So when you simplify the whole of that, it takes you to that formula. So now let's try to substitute all that we know. So guys, remember, tension is what we are calculating. What is the weight? I'm sure you remember very well that this is the weight, which is 1960. Guys, what is the frictional force? Obviously, you were able to notice that the frictional force is that one. So why not saying that? Guys, do we know what is the mass? What is the mass of that container, guys? Do we know?
Yes,
Yes.
sir. You said it was 200. We calculated.
100%. So we calculated the mass to be 200. The acceleration, we were told that it's that. So easy, 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 guys. You just transpose, and then you have your T as your final answer. What is your T, guys?
I got um 2,126.
Did all of you guys get the same answer?
Yes, I also got 2,166.
100%. So obviously, we've got that amount of tension in the upwards direction. So that is how, guys, you score yourself 4 marks. You are most likely to get a mark for for writing the correct formula there, and again for correct substitution on this side of the formula and on that side of the formula, they are going to give you a mark. And again, for the correct answer, they are also going to give you a mark. So you can still say upwards because you know tension as a vector quantity. Guys, did that make sense to everyone?
Yes,
Yes, sir.
2,126.
Yes. Thanks very much, Lerato, for that. So that means I copied it incorrectly. You guys said 2,126. Yeah, so can you see, guys, the tension is more than that one. It's more by 26 Newton. Does it make sense, guys? Do you now notice why you need to fully interpret the given statement and again be able to visualize how your final answer should look like? Do you now, guys, see the benefits of that? Okay, so uh, here comes a question, guys. It says, after an acceleration of a few meters, the container is pulled up at a constant velocity of 0.8 meters per second. So a the question says, what will be the magnitude of the tension in the cable while the container moves upwards at a constant velocity? Anyone who wants to give it a try? And for whatever reason the answer that you give, provide a reason for your answer.
I think it's going to be 2100.
Reason
And
to that?
the reasons, I think, because the acceleration is 0. I'll express is by calculations.
So you're saying it's because acceleration is 0. How do you know acceleration is 0?
Because it was mentioned that the velocity is constant.
But now, Lerato, why is tension not 2126? Why is it not 2126? But why is it 2100?
Yes, it's because the acceleration is 0. So I'm expressing my reason with the calculations. If you may just go back to the third step, say from the calculation from the previous calculations. 3.4.
3.4. Okay. Yes, this is 3.4, ne?
Yes, sir.
Uh-huh.
Go to the third step, sir.
Let's see. Is it this one or this one?
No, yes, that one, sir.
Yes. What about this one?
If we work out the right hand side,
Oh
MA.
yes. Oh yes. Hmm. This is coming nicely. This is coming nicely. So, I'll leave it to you to just wrap up. I know you want me to write 0 there, isn't it?
Yes, sir.
So continue.
Then the left hand side is equated to 0. Now we can transpose the values.
So what is this?
Is 2100.
So we have minus 2100. Then when we transpose, it means tension is equals to 2100 Newton. So this is the best explanation, guys. I doubt I was going to explain it in that way. So this is how it's been explained by means of calculation. So it means, because from the statement they said, what did they say? They said it's moving at a constant velocity. And we know that there's a formula which says acceleration is equals to v final minus v initial over time. So for the fact that it's moving at a constant velocity, it means that minus the same value, it's 0. So it's more like you have 0 over whatever time that it is. So 0 over anything, guys, is just 0, which means, for the fact that this thing is moving at a constant velocity, it means acceleration is equals to 0. So now we know this is our F net, and now we know that our acceleration is 0 in this case. So if acceleration is 0, it makes the whole of that to be 0. Then you just solve for t. When you solve for t, those two gives you 2100. You transpose, then you have positive 2100 newtons. So in short, guys, it means the moment this container starts moving and accelerating at a certain value, that's when this t changes to a different value. But the moment it's either is stationary or the velocity is constant, then it means acceleration is 0. Then that t or tension, it then changes. So guys, are you happy with today's lesson, and can we now conclude on this question?
Yes, sir.
Yes, sir.
Okay. Let me just ask our friends. I notice young WA Nduna sihamba njani lapho. Let me see.
Samba right.
Lebohang Moloi kunjani lapho. Mina enhle Dlamini si right lapho. Kevin
Right,
Oti,
sir.
are you happy there? Grace Makito, kuhamba kahle lapho.
Yeah.
Who else? Mephistos, are you ugrand lapho?
Yeah, so
Okay, so guys, this brings us to the end of our lesson for today. I think in tomorrow's lesson we might continue with trigonometry, especially that part of simplifying and again that part of proving identities. I'm not sure if you guys would be happy for us to continue from where we left off with trigonometry, so that we also don't fall behind on mathematics. Then after we have pushed, we'll also continue with this part of physical sciences. I'm just not sure of what is the next chapter on physical sciences. I'm not sure if it's electricity or if it's which chapter, but we'll see. We'll just discuss that one. So, guys, tomorrow, mathematics, I'll just confirm the details in the group. So, just make sure that if you attended today's lesson until the end of and you enjoyed this lesson, just make sure to raise your hand in the group. It helps me a lot to notice who's active, was able to attend, and so forth. So, guys, have a very good night. I'll see you on our next lesson.